We now continue on with the Introduction to Function handout. We're going to pick up right where we left off on video 1. So we're just below that exercise 2. If we have a formula, we can plug any number from the domain and calculate the corresponding range number. A formula is probably the most common way we represent functions in mathematics. Formulas are going to be incredibly important for us. A formula is like a recipe for the function. It tells us what to do with x to get the corresponding value of y. And usually x is used for input variables and y is used for output. That's not an unbreakable rule, but that's very common. And in this context, x is often called the independent variable and y is the dependent variable. And I just want to sum up these things because we've had lots of vocabulary here. We have domain values that are called inputs, and that corresponds to the independent, that is the independent variable value, and it's usually represented by x. And then we can compare the range values, which we call outputs, and they're represented by the dependent variable, which is usually y. Unfortunately, there's a lot of vocabulary here attached to functions. The output values are always said to be a function of the input values. So if y is an output and x is the input, we say y is a function of x. But notice how we've kind of traded places here because y is the output and x is the input. So we actually say the input second when we say y is a function of x. Now, not all formulas determine functions. Not all formulas that involve equations of x and y determine functions. And it can be kind of difficult to determine whether a formula represents a function or not. We're going to soon see that graphs will make this a lot easier. But right now we're going to do exercise 3 together, where in each case we're going to determine if y is a function of x in each of these formulas. So in part A, we're looking at x squared plus 5y equals 2. And to determine if y is a function of x, what you want to do is you want to try to solve for y. Solve for y means isolate y. So for instance, here, I could subtract x squared from both sides and write this as 5y equals 2 minus x squared. And I can then divide both sides by 5 and say y is equal to 2 minus x squared over 5. If I'm able to solve for y, and there exists just one y value for each x value, in other words, if I plug in a value for x, that's going to determine y. Here in part A, y is a function of x. So we do have a function relationship. Let's look at part B. B is y squared minus x equals 1. Now, again, we want to solve for y. And let's see, add x to both sides. I have y squared equals x plus 1, or 1 plus x, either way is fine. Now to solve for y here, I have to take square roots. And numbers, quantities have 2 square roots, right? So I have to write y equals plus or minus the square root of x plus 1. And that plus or minus sign is a signal here that we do not have a function. Signal that we do not have a function. And that's because there can be, or there are usually 2 values of y that correspond to any x value, right? If I plug in a value for x, even if I plug in 0 for x, I'm going to get plus or minus the square root of 1, positive 1, negative 1. I get 2 y values that correspond to that given x value. Here I could even make a little, you don't have to write this down, but x value of 0 corresponds to both 1 and negative 1 for this relationship. And it's the plus or minus sign that signals to me the fact that I can plug in one value of x and I will get 2 different values of y. So here y is not a function of x. So in part B, we do not have a function. Let's go on to C. C on the handout is y cubed minus x equals 1. Again, solve for y. So y cubed, this is kind of similar to what we just saw, right? I'm going to get y cubed as x plus 1. But now here to solve for y, I have to take cube roots. Y is equal to the cube root of x plus 1. With cube roots, there is no plus or minus sign. So here, because there's no plus or minus sign, a given value of x corresponds to just one value of y. So y is a function of x here. So you need to know there's no plus or minus sign there on the cube root to see that this is a function. Okay, that's C. Let's move on to part D. Y equals the square root of x minus 5. There we go. And y is already solved for. And there is no plus or minus sign. A radical sign by itself does not mean plus or minus. If we start out with a radical sign, this means positive square root only. So in D, because we start out with that radical sign, because we do not have a plus or minus, because y is solved for, here y is a function of x. So you'd say, well, what happened to the plus or minus sign? You only get, I'd say you only get the plus or minus sign when you start out with a quadratic, like in B, that you solve. So when you take square roots of a quadratic, you got to consider the positive and negative square root. Here, we started out with the positive square root only. And then E, x equals y plus 1 over y minus 2. We're actually going to do E in a separate video because this one's getting kind of long. And there's going to be a little bit of algebra involved in part E. So that will be coming up next.